everyone, and welcome to this week's pre-calc lesson. I want to thank everyone who did the work last week. Shout out to those who joined some of the video chats to get some extra help. I'm really just proud of you guys and any of the work that you're doing. So you'll notice that this week you should have already started the Google Slides, and there is a little bit of a review, and now we're going to start some new topics. Before we do that though, I just wanted to go over the identities one more time. So there are the reciprocal identities, and that's basically saying that sine and cosecant are reciprocals. Cosine and secant are reciprocals. And tangent and cotangent are reciprocals. Then we have the quotient. We have the quotient identities, which saying tangent is sine over cosine. Since cotangent is the reciprocal, cotangent is cosine over sine. So those are our first identities that we like to talk about. All right. What else do we have for identities? So now we have the Pythagorean identities. And the big one here is saying that sine squared theta plus cosine squared theta all equals 1. That's the really important one here. That's the one that we use the most often. But later you'll see that we're going to use tan squared theta plus 1 equals secant squared theta. And we're going to use cotangent squared theta plus 1 equals cosecant squared theta. So these two are kind of like the backup ones. They're not as important. This one is the real one. And then the last ones that we're going to talk about are cofunction. So cofunction kind of makes sense in our brain because it has this way of saying, because we have the co in front. So it makes sense that sine of theta equals cosine of pi over 2 minus theta. Sine and cosine, cofunctions. Secant of theta is equal to cosecant pi over 2 minus theta. Secant and cosecant are cofunctions. And then tangent of theta is equal to cotangent of pi over 2 minus theta. Right? Tangent, cotangent, cofunctions. So those are some other really important things to look at. Now, talking to you guys, one of the things that I noticed that was tricking us up were the signs for the Pythagorean identities. So again, when you were looking at the Pythagorean identities, you ended up getting like a square root answer, and then you could either have a positive or negative, and that all depended on where you were in the unit circle. So just remember the unit circle were x comma y, which is cosine sine. And in quadrant 1, cosine is 1, cosine is positive, sine is positive. In quadrant 2, cosine is negative, sine is positive. That's a negative sign. In quadrant 3, cosine is negative, sine is negative. And in quadrant 4, cosine is positive and sine is negative. So depending on where you are, you're going to use those positive and negatives. All right, so what are we learning today? Today we are going to be able to rewrite and simplify trig functions using the identities. So using, I spelled that wrong. Using the identities, we are going to rewrite trig functions. And so let's start with a basic example. So we have cosecant of theta, secant theta. When it's just written like this, it's multiplication minus cotangent of theta. And we want to rewrite this function only using sine and cosine. All right, well, the first thing we have to do is we have to realize how are cosecant, secant, and cotangent related to sine and cosine. Well, in this case, we're gonna use our reciprocal identities and our quotient identities. We know that cosecant and sine are reciprocals, secant and cosine are reciprocals, and cotangent is cosine over sine. So we're gonna use those rules to rewrite this. So we get cosecant is 1 over sine theta, secant is 1 over cosine theta, and cotangent is cosine theta over sine theta. Okay. Well, we can multiply those together and we get 1 over sine theta cosine theta minus cosine theta over sine theta. All right, well, we're subtracting here. In order to subtract or add any type of fractions, we have to get common denominators. In this case, the denominator is sine and cosine. This is the denominator of just sine. So to get common denominators, we just have to multiply. So we get 1 over sine theta cosine theta minus cosine times cosine is cosine squared theta over sine theta cosine theta. So now we have common denominators and we can subtract. And so we just get 1 minus cosine squared theta over sine theta cosine theta. Well, this is our Pythagorean identity. Cosine minus 1 minus cosine is sine squared. So we can rewrite this as sine squared theta over sine theta cosine theta. All right, and so now if we think back to algebra, if I have 2 sines in the numerator, this is sine theta over sine theta cosine theta. One of the signs can cancel and we're left with sine over cosine, which is actually just tangent of theta. And we're going to check this using Desmos. So we started with cosecant, secant minus cotangent. We used the reciprocal rules and the quotient rules to rewrite. We got our common denominators and subtracted. Once we subtracted, we realized that this was really the Pythagorean identity, so we rewrote it as sine squared. We canceled. Sine over cosine is actually tangent. So we can use that to cancel out, we can use Desmos to check the graphs, and I'm going to do that on the Google slides, you'll see. So that's using our rules to rewrite. Okay, we can do another one together. So now we're going to start secant theta minus tangent theta sine theta. All right, and so we're going to start with our reciprocal rules, and we're going to start with the reciprocal rules and the reciprocal identities and the quotient identity. So again, sine, cosecant, and stuff like that. All right, so we have to think to ourselves, secant is the reciprocal of cosine, so this is 1 over cosine theta minus tangent theta is sine over cosine times sine theta. All right, so now we're going to just multiply. We get 1 over cosine theta minus sine squared theta over cosine theta. All right, we're still subtracting, but we have common denominators, so we don't have to do another step. So this is really just 1 minus sine squared theta over cosine theta. All right, well, using our Pythagorean rules, we know that 1 minus sine squared theta is really just cosine squared theta. So this is cosine squared theta over cosine theta. Square cancels, cosine cancels, and we're just left with cosine theta. And again, we're going to check using Desmos. All right, so using our rules, mainly the Pythagorean and the reciprocal rules, we can rewrite our trig functions.